Okay, so this is our diagram. We have two rocks from curling, both are 20 kg, the mass. Rock A is going east at 0.40 meters per second, rock B is stationary. Okay, so let's find the momentum AX for rock A. So we know that's going at 0.40 meters per second, so we can multiply that by 20 kg, so we get 8 ns. So the momentum of AX of rock A is 8 ns. So momentum of rock AY is 0 because there is no y value. For momentum of rock BX is 0 while stationary. After we can find that out, after the collision we can find that out, so we don't know that yet. Okay, for momentum rock BY we can also find that out after the collision, so we don't know that. Okay, so let's draw the diagram for rock B after the collision. So it's going north of east at an angle of 67 degrees. Okay, so we know after the collision it's going at 0.15 meters per second north of east. We also know the mass, so we can find the momentum by multiplying that by the mass, which is 3 ns. Okay, so now we know that we can find the momentum by for rock B. Okay, so by using the trig, sine of 67 degrees is equal to momentum by over momentum 67 degrees. Okay, so we have that. So now we can use the sine of 67 degrees over momentum by over 3 ns. Okay, so now we get momentum by is equal to 2.76 ns. Okay, so we have the momentum of object by, so we can find the momentum of object bx by using cos of 67 degrees over p bx, or momentum 67 degrees. Okay, so cos of 67 degrees over pbx or 3 ns, and we get momentum bx is equal to 1.17 ns. Okay, now we have the momentum bx and the momentum by. We can use the summation of momentum to find momentum ay and momentum ax after the collision. Okay, so for momentum of object A. Okay, so summation of momentum initial must equal summation of momentum final. So okay, so momentum of ax plus momentum of bx must equal momentum ax plus momentum bx after the collision. Okay, so we have that. We know the momentum of ax is 8 ns. We know momentum bx is 0 because it's stationary before the collision. Momentum ax, we have to find that out, plus momentum bx we just found out, which was 1.17 ns. Okay, now we do the calculations. We get momentum ax is equal to 6.83 ns. Okay, so now we know the momentum ax. We can find the momentum ay by using summation again. So summation of momentum initial must equal summation of momentum final. Okay, so momentum ay plus momentum by is equal to momentum ay plus momentum by. Okay, so momentum ay and by is 0 because there was no y value, and momentum for b is stationary. Okay, so momentum ay we have to find that out, plus by, which is 2.76 ns. Okay, so momentum ay is equal to 2.76 ns. Okay, now we have momentum ay and momentum ax. We can find the velocity of object A after the collision. So when we draw the diagram of object A after the collision, it's going as south of east. Okay, now we know the momentum of ax 6.83 ns. We know the momentum ay 2.76 ns. We can use the Pythagorean theorem to find the momentum at the object where it's going. Okay, so a squared plus b squared is equal to c squared. Okay, so 6.83 squared plus 2.76 squared is equal to 7.37 ns. Okay, so this is 7.37 ns. Okay, so now when we have that, we can easily find the velocity by using the law of momentum, which is momentum is equal to mv. Velocity is equal to momentum over m. Velocity is equal to 7.37 ns over 20 kg, and we get 0.37 meters per second. Okay, we have the velocity. Okay, so let's find the angle of object A after the collision. Okay, so now we know it's going south of east, so we use sine -1 is equal to 2.76 ns over 7.37 ns. Okay, so when you use the calculations, 2.76 divided by 7.37, negative sign, so we get 22 degrees south of east. Okay, done.